This content is produced by Pass the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. A strong foundation bolt can still leave a weak connection. That happens when the bolt's too shallow, too close to the end of the sill plate, outside the middle third of the plate, paired with the wrong washer, or surrounded by hardware that is not compatible with treated wood. I want you to remember this. Seismic hardware works as a connected load path, not as a collection of impressive-looking pieces. Think about the path from the wall framing, through the sill plate and washer, into the anchor, and finally into the concrete or grouted masonry. Every interface has to stay engaged. A large bolt does not rescue split wood. A thick plate washer does not rescue inadequate embedment. A correctly placed anchor does not excuse the wrong corrosion protection. And a permanent foundation connection is not a substitute for temporary restraints while a tall wall is being raised. That distinction matters for field supervision. I may be coordinating the concrete crew that places anchors, the framing crew that sets the sill plate, the hold-down installer, and the inspection before concealment. I am not redesigning the structure. I am checking that the approved connection reached the field without a missing step. The prescriptive anchor bolt rules give you a practical inspection framework. For conventional light frame foundation anchorage covered by the source report, the anchor bolt is at least 1/2 inch in diameter. It embeds at least 7 inches into concrete or into the grouted cell of concrete masonry. Bolts are spaced no more than 6 feet on center. Every separate sill plate section has at least 2 bolts, even when that piece of plate is short. I put those limits into one reference table because they work best as a single mental picture. 1/2 inch minimum diameter, 7 inches minimum embedment, 6 feet maximum spacing, 2 bolts minimum per plate section. The end bolt stays no more than 12 inches from the end, but it also stays no closer than 7 bolt diameters. Across the width of the plate, the bolt belongs in the middle third. I use the memory line 7-12-6, 7 inches into the concrete, 12 inches maximum from a plate end, 6 feet maximum between bolts. Then I attach 2 companion checks, at least 2 bolts in every plate section, and the bolt hole stays in the middle third of the plate width. The end distance rule is easy to reverse, so I want to slow it down. The bolt nearest a cut end must be close enough to secure that end, but not so close that the remaining wood is too narrow. The outside limit is 12 inches from the end. The inside limit is 7 bolt diameters from the end. For a 1/2 inch bolt, 7 bolt diameters equals 3 1/2 inches. That gives a placement window from 3 1/2 inches to 12 inches from the cut end. A bolt at 2 inches is too close. A bolt at 14 inches is too far. A bolt at 6 inches falls inside the prescriptive window, assuming the rest of the approved detail is satisfied. The middle third rule applies across the width of the sill plate. Area picture the plate divided lengthwise into 3 equal strips. The anchor hole belongs in the center strip. This leaves more wood on both sides of the bolt shank. When a hole drifts close to an edge, the connection has less wood available to resist splitting or tear out. Embedment is the part that can become expensive after the concrete cures. 7 inches is the minimum depth stated in the source report. The field problem is that the crew also needs enough threaded projection above the concrete for the sill plate, the required washer arrangement, and full nut engagement. The research report does not establish one universal projection height for every assembly, so I would not memorize a made-up number. I would verify the approved detail and the actual hardware stack before the pour. Imagine a concrete crew wet-setting anchors while the slab is still workable. One person focuses only on leaving a neat row of threads above the surface. That can hide a deeper problem. If the anchor is pushed too far down, the required embedment might remain adequate, but the exposed thread may be insufficient. If it is pulled too high, the projection may look generous while the embedment falls short. The supervisor has to protect both sides of the concrete line. Spacing has the same two-sided character. 6 feet on center is a maximum, not a target that overrides every other requirement. A short plate section still needs at least 2 bolts. An end bolt still has to land within the end distance window. Approved plans may require closer spacing or a different engineered connection. The prescriptive minimum is the floor, not permission to ignore a more demanding detail. A plate washer is not decorative hardware. It spreads the force from the nut over a larger area of wood. On the braced wall lines identified in the source report for seismic design categories D and E, the plate washer is at least 3 inches by 3 inches and at least 0.2 to 9 inch thick. I put the washer requirements and stacking checks side by side. The square plate washer provides the broad bearing surface. A diagonally slotted plate washer may be used within the stated slot limits. The slot may be no more than 3/16 of an inch wider than the bolt diameter, and the slot length may not exceed 1 3/4 inches. When that slotted plate washer is used, a standard cut washer goes between the plate washer and the nut. That order is worth hearing twice. Wood, then the large slotted plate washer, then the standard cut washer, then the nut. The small round washer is not replacing the plate washer. It is bridging the slot directly beneath the nut so the nut bears on steel, rather than over an open void. I use a snowshoe comparison for the plate washer, but only for the physical effect. A narrow point concentrates pressure. A broad surface spreads pressure. The larger plate washer spreads bearing force over more wood fiber, reducing the chance that the nut and washer assembly crushes into the sill plate under load. The code dimension is still the code dimension. The analogy only helps explain why surface area matters at that interface. Suppose a framer finds a wet set bolt slightly off the intended line. The tempting shortcut is to enlarge the sill hole and tighten the hardware until everything looks flat. That can conceal a bolt outside the middle third or a washer arrangement that does not match the approved detail. I stop, compare the condition with the plans and permitted hardware, and use an approved correction rather than inventing one under schedule pressure. The same caution applies to hold downs. Hold downs are concentrated engineered devices used where the approved braced wall or shear wall detail calls for resistance to overturning and uplift. The exact anchor, bracket, fastener pattern, edge distance, installation torque, and capacity are not numbers I should invent from a general lesson. I follow the approved structural detail, the listed product instructions, and any required inspection or special inspection procedure. The sill plate itself changes the hardware conversation because wood at the foundation is often preservative treated. According to the source report, wood framing members such as sill plates resting directly on concrete or masonry exterior foundation walls, when less than 8 inches from exposed ground, must be preservative treated or naturally durable wood. Treatment helps the wood resist decay and biological attack, but it also creates a compatibility issue for metal hardware. Fasteners, nuts, and washers in direct contact with preservative-treated wood must use the corrosion-resistant materials identified in the source report. Those include hot-dipped, zinc-coated, galvanized steel, stainless steel, silicon bronze, or copper. The supervision point is not that every shiny fastener is acceptable or every dull fastener is correct. Appearance is not a reliable specification. I check the product identification, packaging, listing, approved documents, and manufacturer information. Strength and corrosion resistance are separate questions. A fastener can look heavy and still be the wrong material for direct contact with treated wood. Consider a hypothetical delivery where ordinary interior-grade nuts and washers are mixed with approved hardware. The pieces may fit and tighten normally, but that does not establish compatibility with the treated sill plate. The immediate condition is a material mismatch at a concealed structural connection. The likely consequence is premature corrosion and a much harder correction after walls and finishes cover the work. This is also a sequencing issue. I want the hardware verified before installation, not after the inspector or superintendent finds a problem. I want substitutions documented before the crew uses them. I want the sill plate, washer, nut, and hold-down components visible at the proper inspection stage. Documentation is part of the load path because it confirms that the field assembly is the assembly that was approved. Anchor bolts and hold downs are related, but they are not interchangeable terms. I think of the regular anchor bolts as the repeated foundation connection along the sill plate. They help resist the horizontal sliding action transferred through the wall and plate. I think of hold downs as concentrated devices at specific wall boundaries, where the approved design addresses overturning and uplift. That distinction prevents two common errors. The first is assuming that closely spaced anchor bolts automatically satisfy a specified hold down. The second is assuming that a hold down eliminates the ordinary sill anchorage along the wall. Each component has a place in the approved load path. The plans tell you where each one belongs. A hold down installation is especially sensitive to coordination. The foundation anchor may need to be placed before concrete. The bracket may require a precise location relative to a wall end, post, or cord member. The wood member may need a specified fastener pattern. The anchor may require a listed nut, washer, coupler, or installation procedure. I treat that whole detail as one system, rather than allowing separate crews to make isolated decisions. Suppose the hold-down anchor lands where the framer wants to cut a plate joint. The wrong response is to slide the bracket a convenient distance and assume the difference is small. The approved design may depend on that exact location. The practical response is to flag the conflict, preserve the condition for review, and obtain an approved correction from the responsible design and building authorities before concealment. This is a testable concept based on the CSLB study guide because it measures supervision, defect recognition, and respect for the approved documents. It does not require the general contractor to calculate engineered uplift capacity. It requires the contractor to know where field judgment ends and design authority begins. Permanent anchor bolts also have a firm boundary during wall raising. California occupational safety rules in the source report address manually raising framed walls that are 15 feet or more in height. Temporary restraints must be used, and anchor bolts alone must not be used for blocking or bracing during that operation. I put this into a short safety decision table. When the wall is 15 feet or taller and is being raised manually, the crew needs dedicated temporary restraints. The foundation anchors are not the sole blocking or bracing method. The supervisor verifies the restraint plan before the lift begins. The reason is practical. A tall framed wall creates a large leverage at its base while the crew rotates it from flat to upright. If the base shifts, the wall can move suddenly and workers can lose control. The cited safety rule does not allow the crew to treat the permanent anchor bolts as a sole temporary hinge or restraint system. It requires dedicated temporary restraints for this operation. Imagine a 16-foot wall framed flat on the deck. The crew proposes to let the bottom plate catch against the projecting anchor bolts while everyone pushes the top upward. I stop that plan. I require the dedicated temporary restraints called for by the safety rule and the site-specific erection method. The correction happens before hands go under load and before momentum makes the operation difficult to stop. I also avoid turning the 15-foot threshold into a false permission for shorter walls. The cited rule specifically addresses walls at or above that height, but every wall raising operation still needs a safe plan appropriate to its weight, sheathing, crew, equipment, wind, access, and site conditions. The source report supports the specific threshold and prohibition. It does not support casual assumptions below the threshold. Now I want to walk the connection in the order I would inspect it. I start before concrete placement. I compare anchor layout with the approved foundation and framing details. I check diameter, intended embedment, end locations, spacing, hold down anchor locations, and conflicts with joints or openings. I make sure the crew has a method to keep anchors from drifting while concrete is placed. After the concrete cures, I check what actually exists, not what the layout marks promised. I verify that anchors are present, sound, and positioned for the required plate. I do not hide a defect by forcing the wood to fit. If an anchor is misplaced, damaged, too shallow, or incompatible with the detail, I preserve the condition and obtain an approved repair method. During sill plate installation, I check that each plate section receives at least 2 bolts. I check the end bolts against the 7 diameter minimum and 12-inch maximum. I check that holes fall in the middle third of the plate. I confirm the plate material is appropriate for its contact and clearance condition. I confirm the nut and washer materials are compatible with treated wood. At braced wall lines where the source-backed plate washer rule applies, I verify the minimum 3-inch square plate and the required thickness. If the plate washer is diagonally slotted, I look for the standard cut washer between the plate washer and the nut. I do not accept a stack merely because the nut feels tight. At hold-down locations, I switch from prescriptive memory to document control. I compare the installed bracket, anchor, post, or cord member, fasteners, and orientation with the approved detail and manufacturer instructions. I check that required inspections occur before concealment. If the field condition does not match, I escalate rather than redesign. Before a tall wall is raised manually, I switch from permanent structure to temporary operations. At 15 feet or more, I verify dedicated temporary restraints and make sure the crew is not relying on the foundation anchor bolts alone. That one change in viewpoint prevents a common supervisory mistake. The hardware that will secure the finished wall is not automatically the hardware that safely controls the wall while it is moving. My final memory connection is the phrase depth, distance, distribution, durability, and documents. Depth means embedment. Distance means spacing, end distance, and the middle third. Distribution means the plate washer spreading bearing force. Durability means compatible hardware at treated wood. Documents means approved plans and manufacturer instructions for hold downs and any correction. If I reduce the anchor numbers to one line, I use 1/2, 7, 6, 2, 7, 12, middle third. 1/2 inch minimum diameter. 7 inches minimum embedment. 6 feet maximum spacing. 2 bolts minimum per plate section. 7 bolt diameters minimum from the end. 12 inches maximum from the end. Middle third across the plate width. Those numbers do not replace the approved plans. They give you a disciplined baseline for spotting conditions that deserve attention. Official preparation resources identify seismic hardware installation as a key area because it combines code memory with supervision. The strongest field move is catching the conflict before concrete cures, before walls cover the hardware, or before a crew begins a risky lift. There is an audio practice quiz for this specific episode on hold downs, anchor bolts, sill plates, and plate washers. I made it audio-based, with the questions read aloud and your answer selected by tapping, because I know you may be studying while driving, working, or moving between job sites. Go to the description below this video. You will see a link that says, Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about the anchorage rules, washer stack, treated wood hardware, hold down coordination, or wall raising safety. I read those questions as a way to see where the material needs a clearer explanation. Subscribe so I can help you stay on track through every episode until you get your license. I know this process has to fit around real work, and I am glad to be the voice helping you keep the details organized.